What's going on in our neighboring galaxy? An alarming signal has been received by the James Webb Telescope, and it came directly from our neighboring galaxy, Andromeda. The galaxy, which is home to trillions of stars, is one of the most beautiful known galaxies in the universe, but it is also dangerous at times. This galaxy devours entire mini-galaxies and is currently hurtling towards our Milky Way at more than 100 kilometers per second. Is the strange signal a first indication of the imminent meeting between the Andromeda galaxy and the Milky Way, or are we dealing with a strange unknown phenomenon? James Webb turned his sharp eyes to the galaxy and is now showing us something amazing. This galaxy has already shown us in an impressive way that it's not what we think it is. In the 1920s, big names like Harlow Shapley, Heber Curtis, and Edwin Hubble conducted research using the latest technologies of the time. Thanks to the achievements of electrical engineering, telescope performance increased significantly in the early 1920s, and for the first time, astronomers were able to look beyond the edges of our galaxy. At that time, Heber Curtis was still one of the researchers who believed that the Milky Way was the entire universe. His colleague Harlow Shapley, however, already suspected that there were other galaxies and that the universe was much larger. Shapley and Hubble had spotted strange nebulous clouds behind the border of the Milky Way. One of them was named the Andromeda Nebula because it hides behind the constellation of Andromeda. At the time, Andromeda was initially regarded by the general scientific community as a simple nebula that was virtually outside the actual universe. In 1924, Hubble achieved a revolutionary breakthrough and was able to prove that Andromeda and several other nebulae discovered were, in fact, galaxies. That's crazy, isn't it? That was just 100 years ago, so for 100 years, we have known about other galaxies and the true nature of Andromeda. Back then, people got their first impression that the universe was even bigger than they had previously imagined. We have experienced such upheavals again and again in our history. People used to think that the Earth was all there was, and that the sun was a hole in the sky through which light from a god shone onto the Earth. Then people thought that the Earth was a disk and that you would fall into nothingness or hell if you went beyond the edge. Galileo Galilei was put under house arrest in the 17th century for his claim that the Earth revolved around the sun, and a few centuries later, the Church finally recognized that the Earth was round. Can you imagine what Galileo would have said about such images, or how the Church of the Middle Ages would have reacted to the idea of galaxies in an almost infinitely large universe, a galaxy twice the size of our Milky Way and with trillions of stars? Around 100 years ago, Andromeda turned out to be not only a galaxy but also a collection of stars far larger and more powerful than our own. Initially, astronomers thought the galaxy was a disk or a ring. Although telescopes had made significant progress in the 1920s, the observation possibilities were still in no way comparable to the technology we have available today. It was only with significantly better imaging that it became apparent that Andromeda is actually a spiral arm galaxy like our Milky Way. Only Andromeda is significantly larger. With a diameter of around 220,000 light-years, Andromeda is about twice as large as our Milky Way, which has a diameter of around 100,000 to 120,000 light-years. Although it's only slightly more than twice as large, it contains far more stars. The Andromeda galaxy is estimated to be home to around 1 trillion stars, whereas we have just 100 to 400 billion stars in the Milky Way. Thanks to the higher star density, Andromeda is a true beacon in the night sky. Astronomers could only dream of such numbers and great details 100 years ago. Nevertheless, you can well imagine how exciting the discovery of other galaxies must have been back then. Today we know for sure that there are around 50 billion galaxies. Estimates assume that there are a total of 100 to 200 billion galaxies in the observable universe. Some calculations even arrive at the astronomical figure of 2 trillion galaxies. The majority of these galaxies are found in a supercluster, which was named the Shapley supercluster in honor of one of the first galaxy researchers. James Webb shows Andromeda as a ring of fire. It seems that every age and era has seen a revolution in science and technology. The telescope named after Edwin Hubble dramatically changed our view of the universe in the mid-1990s, and today with James Webb, we have the best space telescope of all time. With razor-sharp infrared images, this telescope scans every light signal in the universe, no matter how small. Unlike Hubble, Webb detects traces of light in the infrared range with its instruments. The telescope collects every trace of light, no matter how small, and assembles these minimal impulses into incredible images after hours of exposure time. Hubble already provided us with a powerful image of the Andromeda galaxy. Imagine, this image was assembled from thousands of individual images. Now Webb is taking another look at the Andromeda galaxy using unique infrared technology, and once again we are in for a surprise. Every new telescope and every technological advance introduces us to new areas of the universe. Infrared telescopy gives us insights that were unattainable with earlier technologies. One of the major improvements of infrared observations is the ability to reveal dust structures within galaxies. In the Andromeda galaxy, for example, infrared light allows for the first time a clear view of dust rings that have remained hidden in other wavelengths. These dust rings tell the story of star formation within the galaxy and are evidence of dynamic processes. Infrared observations are usually particularly useful for detecting cool objects that do not emit enough heat to produce waves in the visible light spectrum. This makes young stars and their formation regions particularly visible to Webb, and the telescope sees all the cool dust clouds that may eventually become stars. As Webb not only detects the dust but also penetrates it without any problems, we can now see through the dense clouds of gas and dust, revealing the inner structures with active galactic centers and supermassive black holes. Creepy galactic cannibalism. While most of you have probably heard of galaxy mergers, where two galaxies become one, the fact of galactic cannibalism is probably a surprise. Galaxies eating each other sounds like a title from a bad science fiction movie, and yet this phenomenon is an astronomical reality. By cannibalism, galaxy researchers mean processes in which a larger galaxy literally devours the matter of a smaller one. In contrast to mergers, the larger galaxy extracts all the matter from the smaller one and destroys it. The basic structure of the larger of the two remains almost unchanged. This is triggered by gravitational processes. If galaxies come close enough to each other due to their mutual attraction and the difference in size is significant, this can lead to the disintegration of the smaller galaxy. This phenomenon has been observed particularly within galaxy clusters, where many galaxies lie together in a confined space. The gravitational interaction leads to a dynamic reaction in which stars, gas, and dust are pulled away from the smaller galaxy and incorporated into the larger one. The dynamic tidal forces can trigger enormous star formation phases and disrupt the nuclei of the galaxies involved. Are you surprised to hear that the magnificent Andromeda is one such galactic cannibal? Our neighboring galaxy has been shown to have devoured several of its satellite galaxies. Certain structures in the stellar population of Andromeda serve as evidence of these violent acts, and the traces are also visible, for example, in the galaxies M32 and M110, which are still partially visible today. Incidentally, our Milky Way is no innocent party in this cosmic drama. It has already assimilated several smaller galaxies in its history and is currently devouring the Sagittarius dwarf galaxy. Galactic cannibalism probably plays just as big a role in the development of galaxies and the shaping of the large-scale structure of the universe as harmonious marriages between galaxies or even encounters in which galaxies only partially touch and change each other. Due to the fascinating constant movements and interactions, the cosmic networks are constantly changing, and the cosmic networks, in turn, contribute in their own way to the dynamics of the galaxies. All in all, this is a cosmic round dance that we can only explore and understand in fractions. The most powerful crash of all time, Milk-Dromeda. It's true, at this very moment, the Andromeda galaxy is hurtling towards us at a speed of 110 kilometers per second, and we are also moving towards it. The cosmic marriage of the two is inevitable, and it almost seems as if the two are magically attracted to each other. In around 4.5 billion years, the climax of the cosmic spectacle of superlatives will take place. The Milky Way and the Andromeda galaxy will then begin their final merger. The result will be Milk-Dromeda, and the birth of this new galaxy will mark the end of two separate galactic entities. This coming together is not abrupt but a process that will gradually gain intensity over millions of years. As the two get closer and closer, their respective gravitational fields will begin to interact with each other, leading to dramatic changes in the structure of both galaxies. At a certain distance, first, the outer stars will collide. Their orbits will be perturbed by each other's gravitational forces, which can lead to a beautiful albeit chaotic arrangement of stars. Stars and star clusters that were once stable in their galactic disks will then be thrown into new orbits. Some will probably even be catapulted out of the galaxies and then travel through the vastness of intergalactic space without a connection to a galaxy. At the same time, gas and dust between the galaxies are compressed, leading to a new wave of star formation. A firework display of young, brightly shining stars will accompany this galactic wedding. Unlike cannibalism, the two are becoming increasingly intermingled. Some regions are merging harmoniously, while others are undergoing major changes under pressure. At the heart of the two galaxies, the drama becomes even more intense. The colossal central black holes approach each other, orbiting each other in an ever closer dance until they finally merge. This merger is accompanied by the release of massive amounts of energy, and huge jets can shoot out into the surrounding universe at almost the speed of light. During the hundreds of millions of years in which this merger takes place, the appearance of the resulting galaxy will change drastically several times. From the initial spiral structure of both galaxies, their union will create a large elliptical galaxy called Andromeda. Neither Andromeda nor the Milky Way will then be recognizable. Instead, a completely new structure will pass through the universe. Click subscribe now. There are many more video highlights to come.